Okay, so Algebra 2, 10.3, we're talking today about ellipses. So there's a notes paper that corresponds to this if you want to use that to follow along. This will be our last lesson for a few days. From this homework, we'll be doing the odd problems for a night. We'll be doing the even problems for a night. We'll be doing a practice quiz after that, and then taking a quiz. So we're at sort of a gap point after today in this chapter. So circles, you might remember from yesterday, there was one point that was set, and every other point was the same distance away from that one point, and if you do that long enough, sooner or later you created a circle. The idea for ellipses is there's two set points, and if we do the sum, meaning add the distances to those points, you'll always get the same number. So a point like this, it's close to this, it's far from that. If we would add those two distances, we'd get a set number. So maybe this is like 5 inches and that's 10 inches. You add it up, you get 15. A point like this is maybe 7 from this and 8 from that. But you still get 15 if you'd add them up. You know, something over here, you might be 4 from this, with the 11 from that, it still gets to be 15. That's the theme. These two set points, one of them is called a focus, and if you have two of them, the plural of focus isn't focuses, it's foci. So that's what the names of those two set points are. Circles have a center. These ellipses have these points called foci. So that's on the notes. The standard form for an ellipse, if it's centered at the origin, the standard form for an ellipse has to equal 1. You'll get fractions, and it'll have to equal 1. More about that in a minute. Basically, an ellipse is it's an oval shape. There's some other vocabulary that we would want to absorb. There is a point right here called the center, just like there is for a circle. It's right in the center of the ellipse. And then there's a highest point that is called a vertex. There is a lowest point, also called a vertex. There's a farthest left location, also called a vertex. There's a farthest right location, also called a vertex. They aren't corners exactly, but it's kind of like the four corners there of the shape. Farthest right and left, farthest up and down. So in the homework, we'll be needing to look at some equations and generate lists of where's the center, where's the focus, where's the other focus, where are the four vertexes or vertices, two plural options for that word. That's just what we're trying to do. And we'll do some graphing from that. So if I give you an equation like this, based on a mention that I gave about 3 minutes ago, this is not in standard form. To be in standard form, the problem has to equal 1, and you have to have some fractions. So what we're going to have to do, if the problem isn't in standard form, is divide the entire problem by whatever number is here. If it's equal 18, we'll divide everything by 18, because 18 divided by 18 is 1. If this tries to divide by 18, it's going to create a fraction. 2 can't divide by 18, 18 is too big, but if you treat 2 over 18 like a fraction and reduce, that could give us a 9. 9 canceling with 18, treat it like a fraction, 9/18 and reduce. We're going to churn out there a 2, and then we'll try to make some lists. As long as you don't see parentheses in the problem anywhere, the center will be at the origin. It's just the way it goes. The first couple we'll do, no parentheses will be involved, will be centered at the origin all over the place. To do the vertices, what you're going to do is look at the two bottom numbers, 2 and 9, and we're going to have to do square roots of those, and those will tell us where the vertices are. So we do the 9 first, that's easier. If I square root 9, that'll be 3. That's partnered up with y. When we write these ordered pairs, the y's always go second. So if I do this y's fraction, I look at that fraction, the square root of 9 could be 3, it could also be -3. That can give me 2 of the vertices, 3 and -3. I'll just stick 0 for the other coordinate there. Why don't I graph while I do this? We had a center at the origin, so here I go with the center at the origin. This fraction is telling us for y's to go up or down. We're always going to root the number in the fraction, so this is telling me to go up and down 3. So I'm going to go up 3, I'm going to go down 3. The x fraction will tell you how far to go right or left. We also have to root this number. Square root of 2 is a little awkward. We're just going to go with square root of 2. And also the negative square root of 2. The vertices will always be opposites, opposite sides of each other. Those are x's because they came from x's fraction. X's go first. Put 0 in the second slot. And on my graph that I started, x goes right or left. Square root of 2, you might want to grab a calculator to generate. It's about 1.4. So we go over 1 and not quite a half. We go over the other way, 1 and not quite a half. And then we'll make an ellipse, an oval shape. Whoa, went through the wrong spot there. We just want to go through the 4 vertices, wrapping around the center. Then there's points called the foci. To do the foci, we're going to look at both of those numbers. We're going to subtract them and root. 9 minus 2 is 7. We're going to do the root of 7. And the bigger number will dominate these problems. Since y had a bigger number, the root 7 is going to be a y coordinate. And the other focus will be negative root 7. These are always same number, but opposite signs. There's zeros at the beginning of that. Root 7, if you grab a calculator, it's like 2.6 something. Since y was bigger, those are going to be located up and down. So I'm going to go up 2 and like a little more than a half, down 2 and a little more than half a square. So that should do it for that one. Second one, it's about the same thing. So this time the problem is still not equal to 1. So to get this into standard form, it has to equal 1. So to do that, we're going to divide the whole problem, everything, by 16. Whatever number's here will divide by it, so it dividing itself is 1. While we do that, that creates fractions. To be in standard form, you have to have fractions and you have to equal 1. If 16 divides by 16, that's a real nice cancel. We're just going to put that over 1 because we have to have fractions. This was a 1. If we divide by 16, it puts it over 16. And again, we have our fractions. Center, as long as you don't see any parentheses, the center is at the origin. So I'll graph while I do that. I'll do my center right here at the origin. This fraction is going to give us 2x vertices. It's in x's fraction, so this is going to give us 2x vertices. To make that jump, we're just going to do the root. The square root of 16 is 4. So x's fraction, root the number, come up with a 4. That's telling me 4 and negative 4 for x's. These are always just opposite signs. There's 0 in the other slots. This x stuff always sends us right or left. So I'm going to go right 4, I'm going to go left. The y vertices are going to go up or down. Again, we're just looking to do the root. The root of 1 is 1. This is a y fraction, so those are y coordinates. 1s go second. There's zeros in the other slots. This is telling me to go up and down 1. So up square, down square, and then we'll connect those to make an ellipse. To do the foci, we always look to subtract the numbers and root. So subtracting them is 15. Root of 15, you can't do any better than that. Your only real crisis choice is whether to put the root 15 in the first or second position. Last time we put it in the second position because y's fraction had the bigger number. This time x's fraction has the bigger number, so root 15 and its opposite, negative root 15, go in the x slot, with 0 in the second position. To graph those, grab a calculator, root 15, punch it in. It's going to be close to 4, but not quite. I'm going to guess 3.85, but I'll verify that with a piece of machinery here. 3.87, so close enough. So we're going to look to go 3 squares and then a good bit of the next square, almost close to 4. The foci always have to be inside the ellipse. If you ever get foci outside the ellipse, you did something really wrong. Those two centered at the origin. The only difference was x having the bigger number in the one, y having the bigger number in the other one. The last group you'll tackle will look like this, and that is going to have a lot more work to do at the beginning because this looks nothing like those look. So what we're going to have to do is our factor by completing the square kind of skills. So I wrote this big thing down, and before I even got the lesson started, I did a little sorting. I got the x squared and x, anything in the x family in an area. I got anything in the y family moved together in an area. I got the numbers out of the way, and now we're going to factor by completing the square. If there's ever a number with the x squared, it has to come off from everything in the x family. So with the 16, 16 comes off, and that's x squared plus 6x. For the y's, do the same. We need to take off 4 from anything in the y family. Disappointing piece of chalk. So to complete the square, copy the x, copy the sign, half of the number. We've done that a bunch of times before. Missing number here would be a plus 9 because 3 squared is 9. And you have to pay for that over here. Not with a 9, but 9 times 16 is happening, so that's a 144. This would be y minus 1 squared, again copying the sign, half the number. The missing leg here would be an add 1. The payment for that would not be an add 1, because 1 is multiplying 4, so that's an add 4. If we add this all up, that equals 64, and then we're almost there. Again, this problem has to equal 1, and it's right now equaling 64. So we're going to divide everything by the 16, or by a 64. Whatever number is here, we'll divide by it, so the problem can equal 1. So the x plus 3 family, y minus 1 family, making some fractions. 16 goes into 64 4 times, while 4 goes into 64 16 times. A lot of times you might notice these numbers swap. You can get away with that if this times this equals that, which it does here. 16 times 4 equals 64. Those numbers can basically just kind of like switch who they're going with. The center this time is not at the origin because I had said previously if you don't see parentheses in your problem, your center's at the origin. But on this problem, I do see some parentheses, so the center is not at the origin. It's just like the center was for circles. With an x plus 3, you're going to go with negative 3. With a y minus 1, you're going to go with a positive 1. We're going to go opposite signs. To figure out where the other pieces are, I'm going to suggest that you make something that I'll title through the rest of the chapter as a rough draft. Make a rough draft list, like in English class when you write a paper. Your first attempt is not what you turn in. It's just something that kind of gets you started, and then you're going to modify it. I'm going to make a rough draft of facts here and then modify them. So x's fraction has a 4, so I'm going to do the root of 4 and come up with 2's. So there's like a 2, 0 and a negative 2, 0 like we were doing before. Let me do a little graphing while I'm at this. Let's do the center first. The center was, we decided, negative 3, 1. So moving from the center, this thing we just decided about the 2's. When we did the square root of 4 and got 2's, that's going to send us right 2 and left 2 from the center. Likewise, let's do the y's. Y, root the number, we have 4's. So we're going to go with y's of 4's. That's telling me that I should go up 4 from the center and down 4 from the center. To do the foci, we're going to subtract to get 12 and do the root. Root of 12 is better as 2 root 3. We've done that before. Since y has the bigger number, I'm going to stick those as y's. 2 root 3, negative 2 root 3, going with 0. On the graph, root of 12 is like about 3.5. So I would look to go up 3.5 and down 3.5 because we're going that way because y had a bigger number. This longer line right here that cuts the thing in half is called a major axis. The one that goes this way, that's called the minor axis, but the foci will always be on the major axis. And the last thing we have to do to turn the rough draft into real answers is take negative 3 and add it on to every x. Negative 3 is an x, so add negative 3 on to this, add negative 3 to that, add negative 3 to 0, add negative 3 to all the zeros that are firsts, and then take the 1 for the y and add it on all the y's. So this adds 1, this adds 1, this adds 1, this adds 1. This, just write 2 root 3 plus 1. And for that one, I would just write negative 2 root 3 plus 1. That's where we are. So 2 days of homework, then a review sheet is coming. Join a Zoom or email me if you have any questions. I'll try to help you out.